Hello friends, now we are going to study about the element hydrogen, its chemical properties and its physical properties, and later on we'll see with the help of those properties how we can answer some questions related to hydrogen. So Deepak would tell us about hydrogen.
Hello, let's start with hydrogen. Hydrogen is the most abundant element in the universe and it is about 70% of total mass of universe. Okay, so
And this
we will
is the
start.
principal element of the solar system. So
Yeah.
most of the solar system or the universe that we have consists of hydrogen only, right?
Right. We will start with the hydrogen's position in periodic table, then its basic structure and chemical properties, then its uses, etc. So as you can see that hydrogen is the first element in periodic table and it has outer electronic configuration of 1s1.
Okay, so can you tell us Deepak what does 1s1 mean exactly?
1s1 means that is actually the orbital number of the electron in which we will fill this electron.
And S I guess is the subshell, and the next one, the last one is it corresponds to the number of the electrons,
Yeah,
right?
Last one is number of electrons. Okay. So actually its electronic configuration is similar to that of alkali metals. As you can see that this is 1s1. Okay. But its ionization energy is similar to that of halogen atoms.
Which in the periodic table we can see that the first column are the alkali metals, and then in the last but one column we have our halogens.
It's second last.
Last but one, second last,
Okay.
we have the halogens.
Okay. In this table you can see that ionization energy of hydrogen is almost equal to fluorine, but it's very far from lithium.
So here we have some experimental data that suggests what we just said.
Yeah. Okay. So the conclusion is that it sometimes behaves like alkali metals and it sometimes behaves like halogen atoms.
Okay.
Okay. Like halogens, hydrogen also form diatomic molecules and it exists as only diatomic. Actually,
it exists as a diatomic. I think it's the diatomic gas, right?
Yeah, it is diatomic gas.
So it's a diatomic gas.
Then the single hydrogen atom does not exist as it is very unstable.
Okay. So we can see the size is also mentioned. If an electron is out of the atom, it is approximately 1.5 into 10 to the power minus 3 picometer.
Yeah, actually the size of H plus atom is exceptionally small because it has no shells in, like we can see that.
We can see that with the help of a drawing. So this was the hydrogen atom with an electron.
This is the hydrogen atom with an electron, and when we remove one electron from its outer orbital, there is no outer orbital in H plus atoms. The one outer orbital is directly removed.
So just the nucleus is left.
Yeah, just the nucleus is left. That's why the size is exceptionally small. Okay.
And so because of this, we can say that it is unique in behavior.
Yeah.
And that is why it is best placed separately in the periodic table, because from most elements it is not analogous to them. So this was what we learned in this lecture about hydrogen. So first we saw from the starting that hydrogen is the most abundant and almost all of the universe, 70% consists of hydrogen, and then its periodic table, its position in the periodic table, it was to be kept along with alkalis or with halogens, because it has the configuration of 1s1 with one more from a filled one and with one less, which corresponds to these halogens. And then we saw with some experimental data that the hydrogen's ionization enthalpy is too high, which corresponds with fluorine, near to that. But as we saw that for alkali metals, the ionization enthalpy is less, and that is a contradiction if we say that it behaves completely like alkali metals. And then we saw that a single hydrogen without an electron, that is H plus, is very small, and because of this it cannot exist freely, and in nature it exists as H2 gas.
let us see isotopes of hydrogen. Isotopes are those compounds which have same atomic number but different mass number.
Okay.
In this slide you can see that this is not 11, this is 1
1,
1,
1.
1,
Okay,
2
1.
and 1, 3. First one is its atomic number and second one is mass number. In
Okay.
deuterium, first one is atomic number, that is 1, and second one is
Second
mass
one,
number.
mass number.
Okay, same in tritium.
Okay.
Now isotopes differ
From
in
one another by number of neutrons present in it. So how
Yeah.
can you tell us how do the neutrons differ? Or what
Yeah.
is the quantity of neutrons in each one of them?
You can see that the atomic number is same but mass number is different.
Okay.
Mass number is equal to number of protons plus neutrons.
Okay, so basically number of mass
Mass
number.
number
Okay.
equals to number of protons plus number of
B
neutrons.
plus n number of neutrons.
Yeah.
And I think this because they have the same number of protons, that is why we call them the same elements.
Yeah.
Right. Okay.
The number actually atomic number tells us that which one is the element.
Okay.
Position in periodic table. And there.
Atomic number is found out by the number of protons in the nucleus. Right.
Yes.
Okay.
So these isotopes differ only in atomic number, actually same in atomic number but different in mass number. Okay. So protium has no neutrons, deuterium has 1 and tritium has 2
neutrons.
Okay. And this table shows us some properties and their values. First one is relative abundance. For hydrogen, it is almost 99.985. That is, hydrogen
It's a
is
very high number. Okay.
Yeah, hydrogen is the most abundant element of these three, and deuterium is very small, and tritium is almost
Tritium is
negligible.
almost rare. We cannot find
Yeah,
tritium.
the relative abundance of these elements shows us the relative stability of these compounds. That is, hydrogen is most stable out of these three, and deuterium is less stable, and tritium is the
Least stable.
least stable.
Okay.
Okay. Then relative atomic mass. It is almost equal to the mass number of these compounds.
Okay.
And there are some more properties which we will discuss later. Okay. Now we want to discuss some methods how we prepare hydrogen and how we use it. Okay. So let's start with preparation of hydrogen. First one is by action of acids on metal. How we will make this? The first reaction in this is Zn plus H2SO4. Yeah, this will produce ZnSO4 plus H2. H2 is a gaseous compound, it will evaporate.
Okay. So this
That
sign
is-
is for basically evaporate. It will go away.
Yeah, it will go away. Similar reaction is with iron.
Iron.
Okay, in this we will use HCl as a acid, and FeCl2 will produce and H2 will.
Okay.
And actually, what elements will react here? We can
That
decide.
is,
Yeah,
there
we
is a
can decide
table,
with
I think.
electrochemical series. What is
Okay.
electrochemical series? In electrochemical series, the elements which are above hydrogen, they will reduce it. From
Okay.
it, yeah,
Okay,
they will reduce
how do we
it.
say that hydrogen is getting reduced? Can you explain on that?
Yeah, in this you can see that oxidation state of hydrogen is +1 in this compound
Okay.
and 0 here.
Okay.
Okay, so it means that hydrogen atom have accepted an electron.
Okay.
Okay, when you accept an electron, that is called
Okay, then
reduction.
it is called reduction. Okay.
Yeah, reduction. Another one is by action of alkalis on amphoteric metals.
Amphoteric metals.
What are amphoteric metals? These metals are those which can react both with acids and bases.
Okay, so that is why the word
Yeah.
amphoteric, with both acids and
In
bases.
above reactions, we see that we done it with acids and now we are doing it with bases.
Okay.
Okay, we are preparing H2 with reaction of metals with bases.
Okay, so zinc, as we can see, it has
Zinc, aluminium,
yes.
all these are amphoteric metals, and NaOH is a base.
So as we had seen in the that zinc was reacting with H2SO4 also, and it reacts with NaOH also.
Yeah,
So this shows their nature.
Yeah,
of the
this shows
amphoterite
that
metals.
this element is amphoteric. Third one is
Okay.
by action of water and active metals. Active metals are those which are above hydrogen in electrochemical series. These elements are these. These are active metals. Okay. So now we can say that these active metals will react with these. In these reaction, we can see that sodium is reacting with cold H2O and producing H2.
Okay,
Okay.
NaOH plus H2.
And
Okay.
all these metals are reacting with water somehow and producing H2.
And important point is that some are reacting with cold water, some are reacting with hot water, and some with steam.
Yeah.
But the element is basically
The
water.
difference is because
Yes.
some metal are above in electrochemical
Okay,
series
okay.
and some are low. When we
Okay.
go above, then reduction of H2 will, reduction of hydrogen will be easier.
Okay.
Okay, so we need not to give much energy in.
Okay. So that is why later when we take steam, then the heated water, basically the energy
Yeah,
of the heated water
the
also
heat-
is used.
Heated water is to provide activation energy.
Okay.
Okay. The fourth one is by action of water on metal hydrides. Metal hydrides, in those metal hydrides,
What is a metal hydride? Can you tell us?
metal hydrides are the compound of hydrogen with active metals.
Okay.
In these compounds, hydrogen have oxidation state of -1.
Okay.
Generally, its oxidation state is +1, but in these compounds, it is -1. Okay, and lithium is +1.
Okay.
Okay, when we react H2O with LiH, H2, that is hydrogen, is produced.
Okay.
What is happening in this reaction is that here hydrogen
Let's
is
look at the process.
here hydrogen is in
-1.
hydrogen is in -1 and
Okay.
here it is in +1. Okay.
Okay.
And in H2 it is in 0. So it is a disproportionation reaction. Disproportionation reaction is that
Okay.
the same element goes in oxidation as well as in reduction.
Okay.
Okay, so this is
So we can see basically that the hydrogen of LiH is getting oxidized and the hydrogen of H2O is getting reduced, right?
right. Okay. Similarly, these reactions are.
Okay, so this was a lesson and we saw various reactions of hydrogen and how hydrogen can be produced.
Let me complete.
Okay.
Here we can see that CaH2 is commercially called hydrolith.
Okay.
Actually, CaH2 is a very good reducing agent. So it is very important commercially and used in much reactions. Now we will discuss some industrial method to prepare hydrogen. The first one is electrolysis of water. In electrolysis of water, first water dissociates into H plus and OH ions.
OH minus ions.
OH minus ions. These OH minus and H plus ions goes to anode and cathode respectively, and there H plus ion get reduced and OH minus ions get oxidized. Okay. Then at cathode H2 is released and at anode oxygen gas is released.
Okay. So basically we get a hydrogen gas at the cathode.
Yeah.
This is how we prepare it.
So our aim was to produce hydrogen and
Okay, it gets reduced and converted into H2.
okay. The second one is pure hydrogen can be obtained by electrolysis of barium hydroxide because its solution is free from carbonates.
Okay. So this is very important. And
Yeah,
I think it has been asked also one time in the ITJE exam.
Okay.
So
In production of NaOH by electrolysis of brine solution, hydrogen is also produced as a side product. That is
see the reaction here.
Na plus Cl minus plus H2O giving us Cl2 plus H2 plus 2Na plus 2OH minus. Okay. So here our aim was to produce only chlorine gas, but we got H2 gas as a side product. Okay. And fourth one is reaction of steam on
Hydrocarbons.
hydrocarbons. When hydrocarbons are reacted with water, the CO gas is produced and hydrogen gas is also produced.
And the high temperature is important. The condition of high temperature.
Okay, the CO and this mixture of CO gas and H2 gas is called water gas. Okay, now this CO gas is this CO gas can also react with water to give us CO2.
Okay.
Okay, this when this CO gas is reacted with water, the equilibrium here shifts in the forward direction. Okay, fifth one is Lane's process. In Lane's process, we pass steam over spongy iron and H2 is produced. The spongy iron is only a form of iron and it is a commercial name, and we don't have to take anything from spongy iron or anything. Okay, it is simply iron and we get Fe3O4 and H2.
Okay, now we see some properties of hydrogen and the physical properties.
Yeah, first one is physical properties. Physical properties, first one is H2 is colorless, odorless, tasteless gas.
Okay, so we cannot sense if
We
H2
cannot
is
sense
around.
it. And it is slightly soluble in water since it is non-polar in nature. We know that non-polar dissolves in non-polar and polar dissolves in polar.
What is the meaning of non-polar?
Non-polar means that there is no charge on these compounds.
Okay, no
because-
partial charge.
No partial charge on these compounds
Okay,
because
okay.
when we discuss H2O, there is some partial charge, that is -2 on oxygen, +1 on.
So all this, these are not exactly two charges of 1 and -2, these are partial. Right?
Yeah.
Okay.
Yeah. So there is no charge on hydrogen, that's why it is non-polar.
Okay.
Okay. This +2 -1 shows the polarity of.
Okay.
Third one is
Electrons are shifted towards O2 mode,
Yeah.
oxygen mode.
H2 is lightest gas as known. 1 liter of it weighs only 0.00982 gram. That is very less.
Weight of 1 liter. Okay.
Okay. It can be liquefied under high pressure and low temperature because its boiling point and melting point are very less. Okay. So we have to reduce the temperature and increase the pressure to liquefy it.
Okay.
Okay, it's too difficult to liquefy. Okay, as we see that melting point and boiling point are very less, this is because it has a very less interaction between
Okay.
H2
two
molecules.
H2 molecules.
Two H2
Okay, so
molecules. There is only van der Waals force of interaction.
Okay. Intermolecular forces.
Yeah,
of
there is
attraction
no
are very weak.
dipole interaction. Now we see that melting and boiling points of D2 and T2 are higher than H2. This is because these both compounds have higher molecular mass than H2. H2 has molecular mass 2, D2 has 4 and T2 has 6. And melting and boiling points are directly proportional to molecular mass. That's why
Okay.
they have higher melting and boiling points.
So this was the physical properties of hydrogen which we saw, and we'll get more information about hydrogen in the upcoming lecture.